A lifetime of hard work, children laughing in the kitchen, family photos on a restaurant wall, a legacy that lives on. It all comes from the power of a conversation, like the one Tommy Hall had with First Horizon Bank about taking over his father's Charleston-based restaurant business. Now the table is set for a whole new generation. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy. First Horizon Bank, member FDIC.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime Series 26, Episode 108, for broadcast on the 8th of September 2023. Coming up on SpaceTime, a new study shows there are actually fewer black holes than thought busily feeding on anything around them. We look at NASA's Nancy Grace Roman Space Telescope and the Muon g-2 collaboration exploring uncharted territory in the search for new physics. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
When we think of our universe, we often think of galaxies and their central supermassive black holes busily feeding on anything that gets too close. Violent places hosting monsters that we can barely imagine. Now, a new survey looking at a large slice of the cosmos using the James Webb Space Telescope has revealed that active galactic nuclei, that is, feeding supermassive black holes, are a lot rarer than previously thought. The findings, made with Webb's mid-infrared instrument, suggest the universe may be a lot more stable than astronomers and certainly science fiction writers ever imagined. The work, reported in the Astrophysical Journal and on the pre-press physics website archive.org, focused on a long-studied zone of the cosmos which has been dubbed the Extended Growth Strip, located between Ursa Major and the Bootes constellations. Previous observations of the same area were made using the Spitzer Space Telescope, so re-examining the area with a more powerful Webb should reveal lots more active galactic nuclei. The study's lead author, Alison Kilpatrick from the University of Kansas, says the new observations were taken from June last year through to December and were aiming to characterize how galaxies looked during the heyday of star formation in the universe. It all equates to a look-back time of between 7 and 10 billion years. Webb's mid-infrared instrument can see through the veil of dust and gas that can obscure ongoing star formation and hide supermassive black holes ravaging surrounding material. Well, astronomers are now pretty certain that every galaxy does contain a supermassive black hole at its centre. Feeding black holes, those containing active galactic nuclei, are far more spectacular and are great laboratories for studying the universe as a whole. The authors anticipated that the higher resolution Webb telescope survey would locate many more active galactic nuclei than what were found using the Spitzer Space Telescope. However, it turns out that boost in power and sensitivity only revealed a handful of additional galactic nuclei. In other words, there's not as much going on as what had previously been thought. Kirkpatrick says there was no flood of newly discovered supermassive black holes with active galactic nuclei. She says it turns out that these black holes are likely growing at a slower pace than previously believed. And that's intriguing, considering the galaxies Kirkpatrick's been examining do resemble our own Milky Way galaxy as it would have appeared in the past. An important mystery in astronomy lies in understanding how typical supermassive black holes, such as those found in galaxies like the Milky Way, grow and influence their host galaxies. But this study's findings suggest that these black holes are not growing rapidly, absorbing only a limited amount of material, and perhaps not significantly impacting their host galaxies at all. The discovery opens up a whole new perspective on black hole growth, since our current understanding is largely based on the most massive black holes in the biggest galaxies, and those do have a significant effect on their hosts. But smaller black holes likely don't. Another surprising outcome was the lack of dust in these galaxies. By using Webb, astronomers could identify many more smaller galaxies than before, including ones the size of the Milky Way and even smaller, which were previously impossible to see at these redshifts. Now, typically the most massive galaxies have abundant dust due to rapid star formation rates. It's always been assumed that lower mass galaxies would also contain a substantial amount of dust. But they didn't see that, defying expectations, and offers another intriguing discovery. According to Kirkpatrick, this work changes science's understanding of how galaxies grow, especially concerning galaxies like our own Milky Way. The supermassive black hole at the center of our Milky Way galaxy, Sagittarius A star, is located some 27,000 light-years away and is around 4.3 million times the mass of our Sun. And right now, as far as we can tell, it's not doing much. And it hasn't been doing much for a long time. Put simply, Sagittarius A star seems quiet, uneventful, and not displaying much activity. One significant question regarding the Milky Way is whether Sagittarius A star was ever really active, or even went through an active galactic nuclei phase. If most galaxies like ours lack detectable active galactic nuclei, it could imply that our black hole was also not very active in the past. Ultimately, this knowledge will help constrain and measure black hole masses, shedding new light on the origins of black holes, how they grow, and how they evolve. And for now at least, that remains an unanswered question. This is SpaceTime. Still to come, we look at NASA's Nancy Grace Roman Space Telescope and the Muon g-2 collaboration exploring uncharted territory in their search for new physics. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our new sponsor, Incogni, a new data protection service from the same folks who bring you NordVPN. It's a startling fact that everything you do online is being sold, even published without your knowledge. How often do you think about your personal information that's out there on the internet, what it's being used for, and how it's being collated? But there is a silver lining, because you have every right to protect your privacy and ask these data brokers to erase your information. Now, if you're thinking about doing this manually, brace yourselves, because it's going to take years just to go through the whole rigmarole once. And guess what? You'll need to keep this tedious process going every few months. That's because Big Brother's out there continually creating new information and getting new records on all your data. And you'll be surprised to learn just how much data they have on you and where they get it from. But now there's Incogni. It's a game changer. Incogni are experts who'll handle all this for you, ensuring your data is removed from these databases, which in turn will reduce spam and those pesky scam attacks. And the best part is, all their subscriptions are already incredibly affordable. As a special treat for SpaceTime listeners, we'll give you an extra 60% off. Now, to find out more, check out their website and take advantage of our special 60% off offer. Head over to www.incogni.com/Stuart Gary. And Incogni, by the way, is spelled I-N-C-O-G-N-I. That's I-N-C-O-G-N-I. The URL again is www.incogni.com/Stuart Gary. Or simply apply the discount code Stuart Gary at the checkout. So don't let your data be someone else's profit. Take control back and let Incogni do the hard work for you. And of course, you'll find all the URL details in the show notes and on our website. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
A vast team of scientists and engineers are continuing work on NASA's Nancy Grace Roman Space Telescope, which is slated for launch in 2027. Like the James Webb Space Telescope, Roman will study the universe using infrared eyes. But while Webb unravels the beauty and mystery of the cosmos, zooming in to get a detailed look at small parts of the sky, Nancy Grace Roman is going to have a much wider panoramic field of view, surveying large areas of the cosmos all at once. In fact, it'll gather more data than any other NASA mission ever launched, in the process attempting to answer some of the biggest questions in astrophysics. Roman will be searching for extrasolar planets, using gravitational microlensing as a guide. But its real goals will be to test Albert Einstein's theory of general relativity, which has been well tested on the scale of our solar system, but not so much on larger cosmological scales. You see, one of the big problems is that visible matter within our universe should, according to the theory, slow down the expansion of the universe. Yet, during the late 1990s, astronomers discovered the rate of the universe's expansion out from the Big Bang 13.8 billion years ago isn't slowing down. It's actually accelerating. Astronomers have attributed that acceleration to a mysterious force they're calling dark energy. Roman will give scientists data accurately measuring the position and distance of millions of galaxies. It'll provide a chronology of the universe and the growth of cosmic structure, with the end goal of measuring the effects of dark energy and the consistency of general relativity and the curvature of space-time. All this will help astronomers better understand the expansion rate of the universe in different areas. Ultimately, the results will tell if Einstein's theory of gravity needs modification. And that means it'll do nothing less than tell us a bit more about the ultimate fate of the universe. The Roman Space Telescope is based on an existing 2.4 metre wide field of view primary mirror and will carry two scientific experiments. There's the Wide Field Instrument, which is a 300.8 megapixel multiband visible and near-infrared camera. That'll provide a sharpness of images comparable with what was achieved by the Hubble Space Telescope, but over a 0.28 degree field of view. That's 100 times larger than the imaging cameras on Hubble. There's also a chronographic instrument, a high-contrast small field of view camera with a spectrometer attached to it that'll cover visible and near-infrared wavelengths using a novel starlight suppression technology. Although they're separated by 30 years, Roman actually shares a lot of its heritage with the Hubble Space Telescope. But then again, when you think about it, there's far more than just one Hubble Space Telescope. In fact, as far as we know, and that figure's pretty flexible, there are at least 22 Hubble Space Telescopes up there. All of them are using the same basic design adapted for Hubble, and some have been in orbit since 1976. But unlike Hubble, which is pointed up towards the heavens, the others are all pointed down towards the Earth's surface, because they're Earth observation spy satellites, built for the National Reconnaissance Office, America's intelligence agency for space-based surveillance. They've gone by a variety of different official and not-so-official code names, such as KH-11, Kenan, Crystal, Evolved Enhanced Crystal, 1010, Gambit, and Hexagon. But they're generally best known by their most famous code name, Keyhole. There have been at least 6 basic technology upgrades, or blocks, to the Keyhole design since it was first introduced. And 2 of them, known as Misty, were even designed to be stealthy, virtually invisible to radar. Back in 2012, the National Reconnaissance Office donated a pair of spare Block 3 Keyhole spy satellites, complete with spare parts, to NASA, potentially for use as Hubble telescope replacements. The pair were manufactured in the late 1990s and early 2000s and were originally meant to join the constellation of similar Keyhole surveillance satellites orbiting the Earth, but were never used because the design was superseded by newer Block 4 and Block 5 versions. Like Hubble, they were built by Lockheed Martin using the same 2.4 metre main mirror, and like Hubble they were designed to orbit at an altitude of about 500 kilometres. Because they looked down at the Earth and not up into space, they used different optical ancillary equipment and also had a shorter focal length, giving them a wider field of view, around 100 times larger than Hubble's Wide-Field Camera 3 instrument. The 2 telescopes represented a multi-billion-dollar gift from the National Reconnaissance Office to NASA. But they weren't complete. Among other things, they lacked detectors, star trackers, prism wheels and filters. But the good news is they did come complete with bodies, mirrors, payload radiators, and 1.5 metre long struts for mounting spacecraft instruments. And it's one of these 2 telescopes which are now being rebuilt into the Nancy Grace Roman Space Telescope. The team building Roman have now begun integrating and testing the spacecraft's electrical cabling or wiring harness. This enables different parts of the observatory to communicate with one another. Additionally, the harness provides power and helps the central computer monitor the observatory's function by way of an array of sensors. It all brings the mission a step closer to surveying billions of cosmic objects. Project Development Lead Deneen Ferrer from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says just as the central nervous system carries signals throughout the human body, Roman's wiring harness connects its components, providing both power and commands to each electronic system and instrument. Without the harness, there would be no spacecraft. Weighing in at around 454 kilograms, the harness is made up of approximately 32,000 wires and 900 connectors. The wires are all laid out end-to-end. They would span more than 80 kilometres. Directed upwards, they'd be 8 times taller than Mount Everest. Achieving this milestone has been no small task. Over the course of around 2 years now, a team of 11 Goddard technicians have spent time at the workbench and perched on ladders, cutting wires to length, meticulously cleaning each component, and repeatedly connecting everything together. The entire harness was built on an observatory spacecraft mock-up structure before being transported to Goddard Space Environment Simulator, a massive thermal vacuum chamber used in this case for bakeout. Bakeout, that's a term we haven't used before. So what does it mean? Well, when observatories like Roman are sent into space, the resulting vacuum and orbital temperatures can cause certain materials to release harmful vapors. These vapors can condense on the electronics of the spacecraft, creating problems, even short circuits, or they can deposit on sensitive optics, degrading the telescope's performance. So, bakeout is designed to release these gases on Earth so they aren't emitted inside the spacecraft when in space. With bakeout complete, engineers are now weaving the harness through the flight structure in Goddard's big clean room. This ongoing process will continue until most of the spacecraft's components are assembled. In the meantime, the Goddard team will soon begin installing electronics. These will eventually provide power by way of the harness to all of the spacecraft's science instruments. This report from NASA TV.
The Roman Space Telescope's primary structure is ready for the wire harness that powers each system of instruments, gyroscopes, data transfer, and movement. But the harness is nearly 1,000 pounds and 45 miles of continuous wiring. This acts as the central nervous system of the whole observatory, and, like our nerves, is threaded through each major component, making its transfer a delicate operation.
What we're doing today is we're taking the flight harness off of the mock-up that was used to put it in that flight configuration, and we're putting it on the harness transfer tool, which will then be used to pick up the flight harness and put it into the flight structure to then be put and mounted on all the flight hardware and then eventually flown into space.
Each side of the primary structure houses different systems, each with redundant paths of wiring options.
Yeah, so this is the telescope electronics. And over here, the PSE and PDU, which distributes power. Bay 4, this is Bay 4. It's still being completed. This is the kind of the brains of the spacecraft.
With the wiring in place and tested, the team will continue installing all the components into the primary structure over the course of the next year.
And in that report from NASA TV, we heard from harness transfer engineer Lee Huber and electrical engineer Alex Petrov, both from NASA's Goddard Space Flight Center in Greenbelt, Maryland. This is SpaceTime. Still to come, exploring uncharted territory in the search for new physics, and later in the science report, a new study shows that biologically female surgeons are actually better at their jobs than their biological male counterparts. Good to know if you're planning a big op. All that and more still to come on SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
The most precise measurement ever undertaken on an elementary particle's magnetism suggests that the standard model of particle physics is probably right after all. The standard model is the foundation stone of science's understanding of the universe. Researchers are continuously trying to break it down in search of new physics beyond the standard model. For example, we know that the standard model doesn't take account of two really important things, dark energy and dark matter. And that raises the question, what else is missing? Their latest attempt involves the hunt for a discrepancy between predicted and measured values of the magnetic moment of the muon, a heavier cousin to the electron. Had it been found, it would have been seen as a possible signal of undiscovered subatomic particles. Physicists with the Muon g-2 experiment at the US Department of Energy's Fermi National Accelerator Laboratory Fermi Lab have now doubled the precision of the previous best measurement to an estimated error rate of just 201 parts per billion. So, they now have a brand new measurement for a property of the muon called the anomalous magnetic moment, and it improves the precision of their previous result by a factor of 2. The result shows there may not be any sort of discrepancy to explain. That's because the new value bolsters the first result announced back in April 2021. Brendan Casey, a senior scientist at Fermilab, who's worked as part of the Muon g-2 experiment since 2008, says scientists have really been probing new territory here. By making predictions based on the standard model and then comparing those predictions to the experimental results, scientists can discern whether or not the theory is complete, or if there's some physics beyond the standard model that's still missing. Muons are fundamental particles that are similar to electrons but about 200 times as massive. Like electrons, muons have tiny internal magnets that, in the presence of a magnetic field, precess or wobble, sort of like the axis of a spinning top. The precession speed in a given magnetic field depends on the muon's magnetic moment. Now that's typically represented by the letter G. At the simplest level, theory predicts that G should equal 2. And the difference of G from 2, or G minus 2, can be attributed to the muon's interactions with particles in the quantum foam that surrounds it. Quantum foam consists of particle pairs constantly springing into and out of existence. Think of it as energy transforming into matter and then becoming energy again. These particles blink into and out of existence and, like subatomic dance partners, grab the muon's hand and change the way the muon interacts with the magnetic field. Now, the standard model of particle physics incorporates all known dance partner particles and predicts how the quantum foam changes G. And physicists were excited about the possible existence of a yet-to-be-discovered particle that could contribute to the value of G2, because that would open a window to exploring new physics. But like we said, the new experimental result, based on the first 3 years of data and reported in the journal Physical Review Letters, backs the earlier measurement and moves it forward corresponding to a position of 0.20 parts per million. With this measurement, the collaboration's already reached their goal of decreasing one particular type of uncertainty caused by experimental imperfections, known as systematic uncertainties. While the total systematic uncertainties already surpassed the design goal, the larger aspect of uncertainty, statistical uncertainty, is driven by the total amount of data analyzed. It can never disappear, it just gets smaller, and the results available will add an additional 2 years of data to their first result. The Fermilab experiment will reach its ultimate statistical uncertainty once scientists incorporate all 6 years of data into their analysis. And that's something the collaboration hopes to achieve within the next couple of years. To make their measurements, the Muon g-2 collaboration repeatedly sent a beam of muons into a 15.24 meter diameter superconducting magnetic storage ring, where they were circulated 1,000 times at nearly the speed of light. Detectors lining the small particle accelerator ring allowed scientists to determine how rapidly the muons were precessing. Physicists need to then also precisely measure the strength of the magnetic field to then determine the value of G2. The Fermilab experiment reused the same storage ring originally built for its predecessor, the Muon g-2 experiment at the Brookhaven National Laboratory, which was conducted back in 2001. In 2013, the collaboration transported the ring from Long Island, New York to Batavia, Illinois. And over the next 4 years, the collaboration reassembled the experiment and improved their techniques, instrumentation and simulations. The main goal of the Fermilab experiment was to reduce the uncertainty of G2 by a factor of 4 compared to the Brookhaven result. In addition to the larger data set, the latest G2 measurements are enhanced by updates to the Fermilab experiment itself. In fact, the experiment was firing on all cylinders for the final 3 years of data taking, which came to an end on July the 9th, 2023. That's when the collaboration finally shut off the Muon beam, thereby concluding the experiment after 6 years of data collection. They reached their goal of collecting a data set that's more than 21 times the size of Brookhaven's data set. Physicists can calculate the effects of the known standard model dance partners on Muon g-2 to incredible precision. The calculations consider the electromagnetic, the weak and strong nuclear forces, including photons, electrons, quarks, gluons, neutrinos, both Z and W bosons, and the Higgs boson. If the standard model is correct, the ultra-precise prediction should match the experimental measurements. Calculating the standard model prediction for Muon g-2 was very challenging. Back in 2020, the Muon g-2 Theory Initiative announced the best standard model prediction for Muon g-2 available at that time. But the new experimental measurements of the data that feeds into the prediction and a new calculation based on a different theoretical approach, known as lattice gauge theory, are in tension with the 2020 calculation. Scientists on the Muon g-2 Theory Initiative aim to have their new improved prediction available in the next couple of years. That'll consider both theoretical approaches. The collaboration anticipates releasing their final most precise measurement of the Muon's magnetic moment in 2025, in the process setting up the ultimate showdown between the standard model theory and experiment. Needless to say, we'll keep you informed. This is SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study has confirmed that adults with type 2 diabetes who replace sugary drinks with coffee, tea or plain water wind up having lower rates of early death due to cardiovascular disease or other causes. The findings, reported in the British Medical Journal, drew on data from 15,486 American adults at an average age of 61, 74% of whom were women. All of them had type 2 diabetes. The authors found that participants with the highest rates of sugary drinks, meaning more than one serving a day, wound up with a 20% increased risk of death from any cause compared to participants with the lowest intake rate of less than one serving per month. Now, in contrast, high intakes of certain beverages, up to 6 daily servings, were associated with lower mortality, 26% less for coffee drinkers, 21% for tea, 23% for plain water, and 12% for low-fat milk. Paleontologists have discovered the remains of an ancient marine reptile that may have been a filter feeder, just like modern baleen whales. A report in the journal BMC Ecology and Evolution claims Hooposuchus nanchinensis, the remains of which have been dug up in China, had skulls with small features similar to modern-day bowhead or right whales. The authors say the skulls had unusual toothless snouts, and there were grooves around the roof of the mouth which indicate there may have been soft tissue there that played a similar role to the baleen filters found in some modern-day whales. The researchers also note a loose lower jaw that would have allowed the ichthyosaur-like reptile to open its mouth wide enough to take in large gulps of water, and a rigid body, suggesting this may have been a slow swimmer that fed in a style very similar to modern-day whales, which swim with their mouths open near the surface of the ocean and strain food from the water. The team says these findings could be an example of convergent evolution, where similar features evolve independently in different species. Hooposuchus nanchinensis dates back to the early Triassic of the Hubei province and may have reached over a metre in length. A new study has shown that on average, biological female surgeons perform better than their biological male counterparts. The findings, reported in the Journal of the American Medical Association, are based on a joint Canadian-US study of more than 1 million Canadian patients who underwent surgery. The authors found that those treated by biologically female surgeons were less likely than those treated by biological male surgeons to have post-operative problems 90 days and 1 year after surgery. The researchers say they don't know exactly why biological females make better surgeons than biological males, or what could be done to bring biological male surgeons up to the standards of their biological female colleagues. They say that should be the subject of further study. It's the story Big Garlic didn't want you to hear. An Australian garlic company is claiming their research shows that locally grown garlic has demonstrated a 99.9% efficacy against viruses that cause COVID-19 and the common flu. The company's press release claims certain unique Australian-grown garlic varieties demonstrate antiviral activity. The trouble is, they didn't give any details on exactly what these garlic varieties were or why they may have more antiviral properties. And the claims have now been strongly condemned by scientists. Dr. Ian Musgrave, a senior lecturer in pharmacology with the University of Adelaide, says that until clinical trials have been done, no claims can be made about the effects of these extracts for the prevention of treatments like influenza, let alone COVID-19. And Tim Mendham from Australian Skeptics points out Australian garlic producers neglected to mention that the studies had not been published, meaning they've not been peer-reviewed, nor do they mention that these studies were limited to test tube results and not trialled on people.
A recent story appeared in the Australian press suggesting that garlic could be used as a cure for COVID-19 and for influenza and various other things like that. Now, this surprised a lot of people, and there's a bit of digging going on, including by Skeptics, I should add, that the story came from a garlic company. Apparently they had funded research that was done at the Peter Doherty Institute in Melbourne, which is a pretty well-known and respected medical research institute, named after an Australian Nobel Prize winner, so it's got some street cred there. The trouble is with this research was it didn't actually say what the claim was. And the research was done on garlic, but in vitro, as they say, which means it might be useful for treating test tubes, but it's not necessarily proven for treating people. And that was a criticism of it, which the Doherty Institute itself admitted. They said it's not done in humans, the real world, it's done in test tubes, so therefore really you're taking a long leap to suggest that there are definite benefits from it. One of the problems was that one of the Doherty staff made a comment to the press that garlic is known to be good for killing bacteria. It's long been used in traditional Chinese medicine. Problems with that, of course, is that COVID and influenza are viruses, but not bacteria. And traditional Chinese medicine has a lot of problems with it, with a lot of the very, very strange treatments that are included in it. So this very quickly was shot down to the story. Unfortunately for people who are suffering, they're saying chewing on a bit of garlic is not proven to be able to help you. But let's put it that way, not proven. I mean, no one's going to say some way down the track it shows it has some benefit, but it's certainly as far as this particular research, it was overhyped to the extreme.
Does it give you a French accent?
May we.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio.
And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Holiday shopping is so stressful.
It doesn't have to be. BlendJet is the perfect gift for everyone on your list.
BlendJet?
It's the portable blender that lets you make smoothies and shakes anywhere.
That sounds amazing. But what about the price?
That's the best part. BlendJet's Black Friday sale is going on right now. It's their lowest price ever.
I'm sold. Where do I get it?
Just go to blendjet.com. But you've got to hurry. The sale won't last forever. blendjet.com.